JT in the back taking raffle donations, and Greg up here is going to be making a documentary of all this, unfortunately. So raffle tickets are still being accepted, or if you still want to purchase them, you can go back there and get them. We're going to keep doing that until the end of the presentation. We'll have like basically a last call, and then we'll draw for everything. Go ahead and bring Rachel up here. I want to give her a big round of applause and a big thank you. All right, yeah. So not only was she gracious enough to let us come here and crash her place of establishment, she definitely went above and beyond what we would have expected for an event host. She brought in a guest speaker, and she'll introduce her in a second. So come up here. Hi.
Appreciate y'all all coming. Thank you very much. It's our pleasure to do this. We've enjoyed working with the forum, and I know I've learned a lot. Just in the past couple of years, we've really tried to improve our saltwater department, and I know it has a long way to go still, but we are always learning. And one of the ways we learn is we went into a certification at Seachem ourselves, which was a 3-day seminar that was very intensive. Am I not okay? Sorry, they told me not to step outside the black thing. So any input you guys have, we're always willing to listen. We try to take criticism well. But we are, believe that we're trying to improve and trying to add and expand our variety. We have lots and lots of different brands of things that we may not carry in the store, but that are available for us to order for you, and we're happy to do that anytime. But that's enough about me. I'd like to introduce Elizabeth Hyder. Elizabeth has been with Seachem 6 years. She's actually in technical support. She's not a salesperson. Our sales guy actually just had a brand new baby, not him, obviously, his wife, a few days ago, or he would have been here too. He's the one that usually comes to visit me. Elizabeth only comes out to do educational type things. She's in technical support. She has a degree in biology from University of Georgia, which I told her I try not to hold things to.
Sorry about that.
But there's other non-LSU fans here too.
Okay.
Is there such a thing?
I didn't think so, but apparently there's a few. So anything else? I got everything. But thank you, and we thank them very much for coming because they did this at Seachem's expense, and so that was very gracious of them to do. We found, I have to say, that personally, my husband and I, my husband Stephen back there, we have found that there are certain companies that we really like to work with because not only are they technically good, but they are good people, and Seachem is one of those. All the people that we have met and talked to there are good people, and it's the kind of company we like to work with. So that was one of the other reasons we like them a lot. So please introduce or welcome Elizabeth.
Okay, and thank you guys. Thank Rachel and Stephen for having me, and all of you for listening. I hope I don't put anyone to sleep or bore you too badly. I am, like Rachel said, I work in technical support, so I don't get out too much in front of people. So if I stutter or kind of make a fool of myself, please forgive me. But hopefully I can bring something to the table here. At Seachem, we all basically are hobbyists ourselves, and they kind of make it a point for us to be involved in things so that we can deal with customers like yourselves on a very personal basis. So my job, generally, day in and day out, is answering emails and phone calls from customers, just with questions that they have on how our products work and why they work, and how they can use them in their own applications. So hopefully, I can talk on a level I'm going to do a little bit about medications and health. I'm going to try not to focus on Seachem stuff, but obviously if you have any questions along the way, please tell me at any point. So I'll get started. Obviously, fish health, I'm sorry, I know this is a reef club. I'm pretty much going to be focusing on fish diseases at this point. This is kind of my particular interest. I try and we each kind of have our own little things that we really get involved in and like to do. So hopefully this will, you can take something out of this. Like I said, I'm sorry it's not really very reef specific, but hopefully you'll get something out of it. So as we all know, fish health poses quite a unique situation. Fish, because they're constantly exposed to their environment, they basically anything that happens within the water, they're exposed to all the time. So I'm going to talk about fish disease. Fish disease can fall into one of two categories. The first being systemic, and under the systemic category, there's also two subcategories. So iatrogenic conditions, these are going to be things like exposure to ammonia, nitrites, and nitrates. So things that if a fish is exposed to it, their health can be obviously affected by it. Usually if you remove the source, the fish are going to perk up and be a little bit better. There are also congenital conditions, so things that fish are born with. So these things are going to be pretty isolated. They're not going to be moving around from fish to fish. Today I'm going to be focusing mostly on infectious diseases or communicable diseases. So we'll start by talking a little bit about immune response. So immune response is how the body recognizes and defends itself against things that are foreign. So bacteria, parasites, viruses, all of these things are foreign to the fish. So when the fish is exposed to these things, the immune system is going to kick in and try and fight this off. Sorry, I don't think my little thing is working, so I'm going to have to kind of hang close to my computer here. Yep, it might be working. I don't know how to do it. Okay, so we'll talk a little bit about defenses. So defenses are a collection of mechanisms within an organism to protect it against infection. So basically the immune system is going to recognize something as foreign and try and attack it. So the first line of defense in fish is their scales. Just kind of like our skin, basically the scales serve as a physical barrier to basically fight off any impending problem. Now, the epidermis, or the outer layer of the skin, is going to secrete a slime coat. So we all know it's important for fish to have a very healthy slime coat. What this does is inhibit or trap organisms that may be foreign and keep them from entering the body. There's also something called an inflammatory response. So an inflammatory response or inflammation is basically increased blood flow. The idea being to bring white blood cells to the site of the infection. So white blood cells, we have white blood cells and fish have white blood cells. What these do, basically, these are the cells that recognize something that is foreign and actually go after that and attack it. They use a process called phagocytosis, and what they do is actually literally engulf whatever's foreign and get rid of it. So, I just said that. So the fish immune response are profoundly affected by environmental temperature. As we know, fish are cold-blooded organisms, so their body temperatures are going to adjust with the temperature of the water. Now, lower temperatures are going to be immunosuppressive. So if the temperature is very, very low, the fish's immune system is going to be suppressed, and they're not going to be able to fight things off as well. Now, at really high temperatures, parasites can reproduce a lot more quickly. So it's very important to maintain homeostasis, good, perfect temperature for the fish so that their immune system is not compromised, and also so parasites cannot replicate very quickly. All right, so we're talking about some sources of stress. Obviously, inadequate water conditions can bring on a lot of problems for fish. Temperature changes, handling, overcrowding, aggression, disease, poor nutrition, and sometimes even the treatment used can be sources of stress for fish. So some of the results of stress are going to be things like increased blood sugar. So stress can trigger a reaction by the nervous system. We've all heard of fight or flight. So what happens is hormone levels rise, and the idea is to make stored energy, usually in the form of glucose and fat, available to cells so that the cells are primed to get the fish away from the problem. Problem is, the fish can't necessarily get out of the environment. So we have to make sure that we are giving them the best environment to keep them healthy. Another thing that can happen as a result of stress is that osmoregulation can be disrupted. So osmoregulation basically is the idea of maintaining a proper balance of salt and water within the fish. Cells can become too dilute or too concentrated. So if fish are stressed out, this can be disrupted and make them very sick. Respiration and blood pressure obviously will increase, and sources of stress in the immune system can be inhibited. If the immune system becomes compromised or inhibited, they're going to be able to get sick a whole lot easier. We'll see the slime coat will be kind of compromised if there's a stressful environment. So fish won't be able to fight things off as easily because the white blood cells are not available. So we'll talk a little bit about treatment. The first thing we want to do if we think there's a problem is to assess the problem. So are there any signs of stress? Things like clamped fins, if the fish is floating or sinking, it may indicate a problem with the swim bladder. If there's flashing going on, anxiety, gasping at the surface, obviously visible spots or hemorrhaging. These all could be possible problems. So what we want to think about is what is the quality of the water. If the quality of the water looks perfect, is this the right environment for the particular species of fish that we have? Also, is the fish eating? And what are we treating? So all of these things we want to think about before starting with a medication. So some different treatments, obviously quarantine. Whenever possible, we recommend removing the affected fish and kind of getting them into a quarantine tank or isolating the fish so that we're not getting all of our fish sick. And also, if we're going to be treating, a lot of times we need to be, especially in a reef environment, we need to be treating outside of that reef environment. We don't want to be putting copper or anything that's going to be potentially harmful to corals and invertebrates into the main system. Salinity changes can be very helpful. Hyposalinity can really kind of help to throw off the life cycle of parasites. So this is something that people have been very successful in doing. So Cryptocaryon, for example, the tomots can be lysed by hyposalinity, 16 parts per thousand or less, can really help to get throw off the life cycle of the parasites. Also temperature adjustments, like I said, if we can adjust the temperature, sometimes the parasites will not be able to replicate as quickly. Obviously, anytime we're lowering the salinity or changing temperature, we want to make sure we're doing it so that the fish are still going to be okay in that environment. Medications. We want to be as closely as possible. We want to make sure we're treating with the right thing. We don't want to treat a parasitic infection with an antibiotic. We're not going to do any good. So it's important to choose an appropriate medication for the type of disease or infestation that we're dealing with. So we'll be talking about some certain diseases today. We'll go over some parasitic, bacterial, fungal, and viral problems. Did that a little too fast, sorry. Start off by talking about some parasitic infestations. So this first slide will kind of go over parasites at a glance. Parasites obviously are going to have a host organism to survive. They increase their fitness by exploiting the host for food, habitat, and dispersal, and in the process they reduce host fitness, often causing other diseases. So we've probably all seen where fish will start off by developing Cryptocaryon, and because their immune system has become suppressed, then they can get the secondary bacterial or fungal infection. Very common for them to start off with one problem and end up with multiple problems. So parasites that live inside of the host are called endoparasites, and those that live on the surface are called ectoparasites. So it's important to know what we're dealing with so that we can choose the appropriate medication. And parasites have life cycles that are categorized by different stages. So we'll kind of go over the main life cycle of, sorry, I don't know how I had that twice. Okay, so here's the main idea of cryptocarrion. Have we all pretty much dealt with this at some point? Okay. The first stage is when the parasite is visible on the fish. So these spots that are on the fish are actually the parasite burrowing into the skin. This phase is called the trophon stage. What happens is the parasites become adults and they break off and become free swimming. This is the tomon stage. After they become free swimming, they kind of form this cyst around themselves. And then they begin to divide multiple times. So each tomont is capable of producing up to 200 theroms. So they divide and divide and divide within the cyst. Once the cyst becomes basically full, it bursts open and the parasites are free swimming again, and then they can find another host. So the only medication I'm going to talk about that Seachem has is cupramine. This was our very first product that we came out with over 30 years ago. The reason that cupramine is so effective in treating external parasites is that it's fully ionic, like a copper sulfate product. So it's fully ionic, it's got this charge on it that's very, very capable of killing off parasites, but it's bound to this amine group or a nitrogen group. So that makes it very, very safe for the fish while still being effective at killing off the parasites. I don't know what's going on with my slide here, sorry. Cupramine works by inhibiting the osmoregulation of parasites. So like I was talking about osmoregulation with fish, if we can inhibit the osmoregulation of parasites, then they can essentially burst. So we make the cells of the parasites very, very concentrated, and they end up lysing or bursting. So for salt water, we would recommend bringing the copper concentration to 0.5 and leaving it there for 14 days in order to get rid of any external parasite that you may be dealing with. Obviously, we don't want to be running copper with UV or ozone. We want to remove any chemical filtration that we have running so that we're not pulling the medication right back out of the water. I don't know why this one keeps coming up. I'm sorry.
It's a very important topic.
Very. Okay. So we've all seen cryptocarrion in freshwater. We generally refer to it as ick or Ichthyopteris, but in saltwater, the actual parasite that we're dealing with is cryptocarrion. This commonly occurs during season changes. And again, it's characterized by these white spots on the outer surface of the fish. So a lot of times when your fish start coming down with ick, they're going to start having a loss of appetite. They're going to behave very differently. They may be hiding. Going to see a lot of flashing or rubbing against or scraping against decorations or rocks or whatnot, trying to get this fish are trying to get the parasites off of them. So cryptocarrion is not usually fatal, though it can be if left untreated. So the number one agent against cryptocarrion, because it's an ectoparasite, is going to be copper. So first sign of an external parasite, we always recommend copper if possible. It's going to be just the most effective thing. Less severe cases can be treated with malachite green. Malachite green has been proven to be very effective against cryptocarrion or other external parasites, or metronidazole. Metronidazole is an antibiotic that can actually be fed to the fish. So in a reef environment, if you cannot isolate the affected fish, but you've got to treat the problem, you can actually use metronidazole within a medicated food mix so that you're basically minimizing the loss of the medication to the water column so that your corals and your invertebrates are not being exposed to it, but it still goes after the parasite and can kill that off. Velvet's another problem that some of you may have seen. Velvet is caused by a parasite of the genera Udinium, most often Amyludinium. So these are much smaller spots than Cryptocaryon. Velvet's pretty much characterized by a dusty sheen, so it's kind of smaller spots, more concentrated over the body. It's got this yellow kind of dusty appearance to it. It's a protozoan parasite, which basically a protozoan parasite is a one-celled organism, so it's very, very small and therefore very difficult to treat. So sometimes you need to treat longer than you would for Cryptocaryon. Again, it's not usually fatal and less commonly encountered than other parasites, but the treatment would be identical to crypto. So copper would be the first and best thing to do to treat for velvet. If you can't do copper, then something like malachite green or a metronidazole-based medication. Am I boring you guys to death?
No,
Okay.
I know.
Yeah.
Sorry.
No, it just makes me miss my kids. That's hilarious. Okay, also velvet is an assisting parasite. So like Cryptocaryon, it has this cyst stage, but it lasts longer with velvet. So we're generally gonna have to treat longer with copper if we're dealing with velvet. Again, lowering the temperature can stop the divisions of the tomots, or a freshwater bath can be very effective. You having a rough day, huh? And you thought you were out of school for Thanksgiving. All right, Brooklynella. Have you guys ever seen Brooklynella? Yeah?
Yep.
A lot of times by the time you guys get the fish, it's already pretty much killed them off. This is a very, very insidious parasitic infection. A lot of times clownfish are going to be the most susceptible to this. Brooklynella attacks the gills first, so at the onset the fish will scrape up against objects. They develop this really rapid respiration, and they will go to the surface or hang out near the outlets, basically trying to get that oxygen. But it just keeps developing and keeps this very heavy mucus will develop, and it can suffocate them very quickly. So Brooklynella can be lethal within hours, but generally within 2 to 3 days it's going to be fatal if it's not treated. If it's caught early, we have a medication that's called Paragard. Paragard is a broad spectrum medication that will address ectoparasites, bacterial and fungal problems. It's got malachite green, so malachite green is the effective ingredient in Paragard. So if you see signs of Brooklynella, best thing to do is get some malachite green into the system immediately. Any questions on parasites? We're going to move on to bacterial problems. Sorry, I'm usually talking about all Seachem stuff, so sometimes it's hard not to focus on that. So forgive me if I'm stuttering or anything like that. I don't know why this keeps happening.
The peanut gallery back here suggests it's an apple problem.
Gotta be, huh? I think it's an Elizabeth problem.
Sorry, what?
Uh-oh, you opened up a can of worms there. Okay, so this is a generalized bacterial cell structure. Bacteria are prokaryotes. So prokaryotes, unlike animal cells or our cells, they lack this thing called a cell wall. So basically all of the components of the, the inside part of the cell are kind of just loose within the cell. In eukaryotes, they each have their own little membranes, basically. Some of the important things here are the cell wall. So the cell wall is going to be what gives the bacteria its shape. There are different shapes of bacteria. So we have rod-shaped bacteria, we have sphere-shaped bacteria, and then the spiral-shaped bacteria. Let's see, what else is important? Flagella, this is going to be basically what kind of helps the cells to be mobile so that they can get around and get to different places to attack the fish. Probably the most important thing to note are these ribosomes. Ribosomes are where protein synthesis occurs. So as we probably know, DNA is made up of proteins. Proteins are kind of the backbone of DNA, and DNA is obviously what allows things to replicate, or that's basically the genetic code. So the reason I'm going over this is because a lot of antibiotics that we're going to be dealing with kind of go after the ribosomes and attack the ribosomes so that they cannot, basically, they can't proliferate, they can't keep multiplying. So, there are different types of bacteria, gram-positive bacteria and gram-negative bacteria. Most of the problems that we're going to be dealing with in the aquarium hobby are going to be gram-negative bacteria. So we all have, obviously and hopefully, a well-established biological filter. Most of the bacteria that are going to be present in our biological filter are going to be gram-positive bacteria. Most of the problem bacteria are going to be gram-negative bacteria. So sometimes you can get an antibiotic that can go after gram-negative bacteria, kill off the problem, and not have a significant impact upon your biological filter. Now, a lot of times we're not going to be at home doing these gram stains and whatnot, so we just need to pick out a broad spectrum antibiotic that can kill off the problem that we're dealing with. So this guy named Hans Christian Graham actually developed a staining technique to differentiate between gram-negative bacteria and gram-positive bacteria. The main difference between these two is something called lipopolysaccharide. Just basically allows the different types of bacteria to stain differently. I'll talk a little bit about how antibiotics work. They're going to all work to destroy the biological process the bacteria need to survive or to replicate. So we have different types. So basically some antibiotics will go after the ribosomes. Again, the ribosomes are where that protein synthesis occurs. So if we can go after those, the proteins cannot develop, the DNA or the genetic code just stops. We also have beta-lactam antibiotics. What these do is inhibit cell wall synthesis. So like I said, when we had that picture up of the bacterial cell, certain types of drugs that go after, or that are beta-lactam antibiotics, will go after the cell wall and degrade the integrity of the cell. Again, different idea of attacking it, but the idea being the cells can't replicate, they can't multiply, we kill off what is causing the problem. Some will just go after the DNA directly, and then some will go after the cell wall directly. So different ways of going about it, but however we can kill off the bacteria, the problem can stop. Now, with that said, it's important not to just, put antibiotics in the tank at any time. So a lot of us will treat prophylactically with things like copper or Paragard, malachite green. That's okay to do, but we don't want to ever treat with an antibiotic if we don't actually have a problem. Just like if we were to have strep throat or something, and our doctor prescribes an antibiotic, you don't want to overuse it. You don't want to take an antibiotic when you don't actually have a problem. Bacteria can develop a resistance to antibiotics. And also you want to make sure that you finish out the entire recommended treatment. So if you have a bacterial problem with your fish and you want to use an antibiotic, it's important to make sure that you use it exactly as directed. So if it says dose it, do 7 doses, but your fish looks better after 2 doses, you want to finish out the 7 doses because basically any bacteria that were not killed off can become stronger, they can mutate, and they can cause a reoccurrence. Oh, I know why this is not happening, because I'm pressing the wrong button. Well, that makes a lot of sense. Wow. Okay. So fin rot is a problem that generally occurs when water quality is not where it should be. So it's caused by a bacteria called Aeromonas or Pseudomonas in salt water. And what happens is the fin and tail literally begins to rot away. If it's left untreated, it can form ulcers, and basically the bacteria that are causing the problem with the fin rot can get into the body, enter the bloodstream, and cause internal bacterial problems. So it's important to treat it immediately. Most of the time we're going to only see fin rot in fresh water, but it certainly can happen if the water quality is not good in salt water. So again, this is a bacterial infection. It's going to be best treated with a kanamycin-based medication. Kanamycin sulfate is going to be the best thing to do to treat fin rot and to prevent other bacterial problems. So if fin rot is left untreated, it can lead to a problem called hemorrhagic septicemia. So hemorrhagic septicemia is basically when the bacteria has entered the bloodstream. So it's literally inside the fish. What happens here is we'll see red lines forming along the fish, and this is from internal inflammation. So it's increased blood flow trying to bring those white blood cells to attack the bacteria. So again, we want to make sure we treat with a good antibiotic, broad spectrum antibiotic.
It's like gangrene for fish.
Yeah, lovely. Dropsy is another internal bacterial infection that can occur. Again, a lot of times we're going to see this in freshwater fish, but basically an infection here will go after the kidneys and attack the kidneys. And the kidneys obviously function to remove waste from the body. So if the kidneys begin shutting down, then you have a fluid accumulation within the body. So the fish will appear bloated, and oftentimes the scales will kind of pine cone out, and it's just because the kidneys are not working or functioning properly to get rid of the bacteria or get rid of the waste in the body. So kanamycin-based product again is going to be the #1 choice for this. And finally, I'll go through fungal problems. So fungus or saprolegnia, these will start off as white threads that will build up their mass until they look like puffs of cotton. And if left untreated, these threads can basically go into the body and start attacking the internal organs. So a lot of times fungus are pretty harmless until they start getting into the body. So generally we're going to see this as a secondary infection. It's not something that just kind of pops up on its own. But if a fish is already having a problem with a parasite, their immune system is going to become suppressed, and then they're going to be more apt to develop a secondary fungal infection. #1 thing for fungus would be malachite green. That would be the best thing to treat to get rid of that. And we'll finish up by talking about viral infections. Viruses are kind of a totally different beast from parasites or bacteria or fungal problems. And that's because they actually live inside the living cells of a host. So they rely on the host for their own growth and reproduction. So unlike bacteria or fungal problems, viruses don't have their own organelles for their metabolism, so they must rely on their host. And that's because they're very, very small, and again, they're living inside of the cells of the host. They're very difficult to treat. They're very difficult to sometimes to even diagnose. Problem is that viral diseases can't really be controlled with medication because they use the host's own cells for the reproduction. So if you think you've got a fish with a viral problem, the best thing you can do is just provide good nursing care. So obviously maintaining excellent water quality, feeding the fish a high quality diet, and keeping sick or potentially infected stock separate from other fish. Fish, generally saltwater angels are going to be most commonly affected by viral infections. So lymphocystis is one that some of you may have seen. This is a true virus. There's obviously not a vaccine for it. We can't really treat for it with an antibiotic. That's not going to do any good. Copper is not going to do any good. So we just need to make sure that we're keeping good water quality. That's the best thing we can do. Sometimes the symptoms can be treated with something like Paragard, which has malachite green, but this is pretty harmless. Sometimes the lesions will just go away on their own even. So when choosing a treatment, I actually brought a little handout here, but basically Seachem provides a lot of different medications for some of the problems that you guys may be dealing with. I have a little chart that kind of gives some of the diseases that you might be dealing with and what medications may be a good choice, if you have a problem pop up. But obviously prevention is key. Best thing we can do is to try and prevent impending problems rather than having to treat. So always recommend quarantining new fish and medicating even without signs of infection. So copper, again, can be a very, very good prophylactic agent, or malachite green as well. Of course, no antibiotics if you don't have a problem. Don't try and treat with an antibiotic prophylactically. Obviously, when buying new fish, observe the fish before purchasing. No, Rachel and Stephen aren't going to be sending you home with anybody who's sick, but not a bad idea to quarantine anyway. Maintain good water quality and avoid acute exposure to things like ammonia, nitrite, and nitrate. We want to maintain a consistent temperature and pH, and also provide a wide range of nutrients for overall health. I think that's pretty much all I have. Oh, actually, I guess some general do's and don'ts of medicating that we recommend. Obviously, if you're medicating, you want to remove carbon or any chemical filtration so that you're not pulling the medication right back out of the water. Turn off UV. UV, especially if you're treating with copper, it can break the copper down into a toxic form. So cupramine, for example, has a +2 charge on it, which is that's why it's so effective in killing parasites, but also safe for the fish. If UV is running at the same time, or any kind of reducing agents like a water conditioner or clarifying agent, those can actually work to reduce the copper to a +1 charge, which is very toxic to fish. So with cupramine or any copper specifically, no UV, no water conditioners, no clarifying agents in conjunction. Whenever possible, treat in the quarantine tank. Obviously, for reefs, we don't want to really be treating in the reef itself. And another important thing when you're medicating is to regularly add a bacterial supplement. Like I said, even if your antibiotic is pretty specific and trying to go after gram-negative bacteria, some of your good bacteria are going to be killed off. So important to add a bacterial supplement regularly to boost your biological filtration. Y'all still awake? I heard you snoring. And like I said, I did bring this little chart of problems that you may deal with and what we would recommend treating with. Sorry, try not to make it too Seachem focused, like I said, but that's kind of what I know.
Yeah, you gotta get a little,
That's good.
push in there somewhere. Is there any questions, anybody? About the presentation?
I guess the only question I would have is like, is there any possible way that you could send like your PDF formats, all that, of like everything you did?
Yes.
So maybe we could post it up on the forum, so that in case anybody sets up a new tank, needs a cycle, and we're able to like target exactly what it is and how to treat it with your product.
Yep, certainly. Yeah, I gave you my card, didn't I?
No?
I've got it.
Okay, I'll give you one as well,
Good.
in case I forget.
Okay.
Just email me. No, I'll get it.
Cool. Well, that was a great presentation. Thank you again. We are gonna do some raffling. Last call for raffle tickets. So, if somebody else decides they want to put in that winning ticket right now, we're gonna get in and just get that process started.